report my research work about the stress deformed state of compressed band and stretched band wooden structure. It's via Ukrainian authors from for university from Ukraine. It's from Kyiv, Rivne, Lviv, and Lutsk. It's about the wood and the use of wood in building structure contributes to the economic development of any country. Wood is an economical treasure that has the ability to regenerate. Modern authors associate wood with oxygen, which is produced by wood during its entire existence. It can be argued that the use of wood as a building material will increase the oxygen reserves on the planet. The main advantages of structural wood over other materials such as reinforcement concrete and metal is the low weight of the structure. The low weight of the structure allows to reduce the constant load on the structure by reducing their volume. Disadvantages of structured wood include damage by insects and fungi, height, heterogeneity, and flexibility of the material. Damage to wood by biological pests is overcome by treating wood with chemical protective substances. The heterogeneity of wood is overcome by quality control, as well as the formation of structure from small elements using formaldehyde and polyurethane glues. Slide 2 shows the tension and compression strain diagram for wood and stress deformed state of typical strain wood beam. The height flexibility of wooden elements is associated with a small module of elasticity of wood. It's MOE, as well as a rheological property, creeps and relaxation. To reduce the influence of rheological properties on the wood elements, as well as reduce the flexibility of wood structure, it is possible to use a reinforcement of structure with height stiffness characteristic. On slide 3, you can see comparison of the deformation diagrams. It's a wood, metal fittings, carbon fiber reinforcement, basalt fiber reinforcement, glass fiber reinforcement. Metal reinforcement and carbon reinforcement is the best reinforcement. The material have a height model of elasticity. Therefore, the main task of our work was to develop a basis for calculation and modeling the work of structure reinforcement with the metal and carbon rods or tapes. At the same time, the basis for the calculation should take into account the elastic plastic model of wood deformation and the features of the deformation of reinforcement materials. Slide 4 shows the stresses deformed state of reinforcement wooden beam. The slide describes all the necessary equations for determining stress strain state of the cross section or stress deformed state. We provide the basic for calculations the stress deformed state, which includes images of structure under different types of loading. The first case is shown on slide 5. In this case, the structure deformed state of the reinforcement banded curved wooden element have predominant action of the internal moment. In this case, tensile and compression zones appear in the cross section. In the second case, slide 6, we have predominant compressive force. In that case, the entire cross section is compressed. The first and second case of state we can often see in structural elements in which bending with compression occurs. Such elements include arches, curved beams, columns, to which force is applied with eccentricity. The third and fourth case are related to occurrence of tension in the cross-section. Slide 7 shows stress-deformed state of cantilever handing part of the curved beam cover construction, like stadium bleachers. In this case, the entire cross-section in tensile, there is a case in which there is a predominant moment. Cross-section in that case will be compressed and tensiled. Stretch can only occur for hinging and cantilever cases. Such cases of structure occur very rarely. Slide 8 shows a table of equilibrium equation for all cases of compressed band and stretched deformed status. It can be seen from the table that the equilibrium equation for all cases do not differ much. However, they differ in the number of internal forces and mathematical signs. The main difference in the consideration of tension and compression by material deformation diagrams. The tension and compression diagrams of wood are completely different, and the use of materials for reinforcement also has its own characteristic. It is possible to reinforce the stretched and compressed zone with metal fittings. However, reinforcement with fiber reinforcement composite is possible in the tension zone. And conclusion of our report. Main conclusion. The determination of the stress-deformed state of wood, which is a part of the deformation method, is proposed. Deformation method can be used for theoretical and numerical modeling and calculation of bending wooden elements with an without composite reinforcement. The methodology in part of the theoretical foundation for modeling the work of elastic plastic elements. And modern standards allow determining only limited state of structure, taking into account the stress-deformed state of the bending element will allow predicting the work of wood during its manufacture, operation, and failure. The deformation methods allows to expand the understanding of the work of wooden element, thereby increasing their cost effectiveness and reliability. This concludes of our reports. Thank you for your attention.